This is the last video in the series devoted to n-Tuple Bessey sequences of order 8. Okay, and as you can see, I have a good selection of cards on the table here, and quite honestly, I could give you a very long time looking at this, and you would really not see anything interesting in terms of structure. Okay, so any structure I might have in mind is completely invisible right now, as you'll see later. Okay, so let's go ahead and gather these 40 cards. We're working with 40 cards today. Now, since we both saw the cards, if you have a photographic memory, I went through graduate school with somebody who had a photo, or has, I guess, maybe still, has a photographic memory, and it was quite an irritating thing for the rest of the graduate students, actually. We felt like he was cheating. But even if you had a photographic memory, you would have a hard time following the movement of the cards. We'll go ahead and mix them so that no one knows where anything is. That was a Klondike shuffle, by the way. Why don't we follow that up with a left-right? This will really continue to just move those cards far away from where they were originally. Okay? And boy, would this be hard to track. I can't imagine being able to do that. Okay? Would you like left on right or right on left? You want left on right? Sure? Okay. That's just fine. Why don't we do another mixing procedure? It's called the first shall be last, the last shall be first. This is where I just begin dealing the cards until you say stop, and then I deal into another pile. Maybe you say stop there. Okay, tell me when I should stop. Stop there. Okay. Stop there. Very good. Okay, very good. So this is called first shall be last, last shall be first, because you stack them in the opposite order to which they were dealt. Okay, and that makes sense to kind of help mix them further. Why don't we also deal down the cards into, let's see, 8 piles of 5 cards each. So maybe we'll have one there. I think that's 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Very good. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that should leave 5 for the final pile. Okay, let's see. How would you like these stacked? We could stack the top row on top of the bottom, or the bottom on top of the top. Bottom on top? Okay, that would be just fine. Many ways to stack these, of course. We could stack from left to right, right to left. We can even do a leapfrog stacking. This is where you leap over the neighbor. Which of those, 4, I guess, different stacking procedures. You want left to right, leapfrog. Okay, so this is where you pick up the first one on the left and then leap over its neighbor. This one here leaps over its neighbor. How would you like these stacked? Right on left? Okay. Very good. Okay. I think we've done enough mixing. I can't imagine anyone knows where anything is at this point. Since we've dealt out the cards into 8 piles, why don't we go ahead and deal them out into 5 as well? Okay, because 5 divides evenly into 40, so that would be maybe a good reason for doing that. Now, if we do this, of course, if you think about how many cards we have, we're going to go ahead and have 8 cards in each of these 5 piles. Okay? So as long as I'm doing it correctly, I think I have. Okay, very good. Okay, so we have these 5 piles here, which have been arrived at by crazy mixing of the cards and scrambling of the order of the cards, okay? But I thought we would go ahead and just mix these further. So if there are savants out there that to this point have been able to track where the cards are exactly, let's go ahead and just eliminate that possibility now. So what we're going to do now is I'm going to allow you, and I want, see at this point, you're making, well, you've made some choices already, of course, but you're going to make some choices that will really affect the outcome, and this will be out of my control. And so we have these 8 cards, and so if you've watched any of the videos on the Hidden Structures channel, we've shown you a number of really powerful shuffles. So if you think back to the shuffles that we've shown you, are there any of those that you would like us to perform on this first little packet? A mange? Okay, so that comes in 2 varieties, over, under, or under, over. Which of those 2 would you like? You want under, over. Okay, so how this works is you push the top card into your other hand, and then this would go under, over, under, over, under, over, under. Okay, very good. Okay, what would you like me to do with this next packet? A Pharaoh shuffle? You remember that. That's pretty surprising, actually. So a Pharaoh shuffle is where you break a packet exactly in half, and then technically there's a Pharaoh in and a Pharaoh out, depending on how you interlace them. But we can go ahead and do either one of those. That's just fine. Okay, so that's a Pharaoh shuffle. What about for this one? Which of all the shuffles would you like us to use? Down, under. Okay, we've done that one before, but so down, under, down, under, down, under, down, under, down, under, down, under, down. Last one goes on top. Okay, 2 more piles. Which of the remaining ones? In fact, there's many of them. There's dozens of shuffles we could use. You want the Bessey 1-1. Wow, okay. Well, good for you for even remembering the name, I guess. So how this works is you take the top card off into your other hand, and then the bottom card off, just a single card. So you go 1 from the top, bottom, top, bottom, top, bottom. Okay, so that's a Bessey 1-1. And then what about for the last packet? Oh, okay, okay. So you want to do a 50% under, down. Whoa, I can't believe you remember that shuffle. Okay, now we've done a full down, under. So you're asking for just 50%. That's kind of interesting. So just under, down, half of them, essentially. Okay, we'll do that. So how this works is the first card goes under, down, under, down, under, down, under, down. That's half of them, right? And then you just drop the rest on top. In fact, we could have randomly stacked those, so sorry I didn't give you that choice. Okay, would you like to mix any of these further? You do. Which one? The one in the middle? Okay. So what would you like to do? Push off pairs. The abbreviation is POP, pop, I guess. Push off pairs. Okay. So this is what you do is you just push off pairs of cards like this. And now we can stack from left to right, right to left, or leapfrog. You want to go left to right, leapfrog. Okay, well, that's really going to mix the cards thoroughly here. Okay, that one leaps over there. How would you like these stacked? Right on left? Okay, very, very good. Okay, now for each of these piles, we're going to quickly divide it essentially in half. But we don't want to do something so obvious that we just take the top half and then the bottom half, okay? Because, that really could be suspicious. These cards could now be in some kind of special order, right? So if you think about it, all of the dealing that we've done has involved even-sized piles. So why don't we go ahead and we'll deal the cards into 3 piles, okay? So that will really begin to mix the cards within these packets further. And then what we'll do is we'll go ahead and Klondike pairs to the table. That. Now, how would you like these stacked? Well, this one picked up first, one on the left, bottom one down here, then the far right. Okay, and then from here, what we can do now, if you were here, I would just have you perform a well, if you know how to do a Charlier shuffle, which is what I'm doing here. It really is a messy little shuffle here, or you can just cut the cards if you would like. Okay, and then to finish, we'll go ahead and just deal the cards into 4 piles. Okay, so why don't we go ahead and we'll start to gather our little piles of 4 cards. And so what we're hoping for is 10 piles of 4 cards where the mixing has been done in such a way that no one could possibly know or have been able to track which cards are where. Okay, so we have 2 piles of 4. We need to get another set of 2 piles of 4. So why don't we repeat that same funny little triangle deal. So that will actually be the same. But maybe what we'll do differently here is we'll just, in fact, you can kind of tell me where I should have given you a chance to tell me, where to put those. Now, how would you like these stacked? Okay, bottom left, bottom right, top, and of course top left. Okay, and then we can go ahead and do a Charlier shuffle like we've done before. Okay, and then we can deal those into 2 piles, and then we'll have 2 more piles of 4. I'm really interested in knowing what's in these little piles. Okay, so getting close here, so why don't we go ahead and deal into 3 piles like we've done before. And then I think what we'll do here is we'll just deal down 4 cards into 1 pile, and the remaining cards will constitute another pile, okay? Because I'm sure you're kind of running out of steam watching this. Okay, when we do our cool little triangle deal. In fact, this time, let's make it even easier. We'll just push off the top 4. Kind of speed things along here, okay? And then our last one, I'll go ahead and just use my intuition to divide these into 2 piles of 4, okay? So, see, maybe I'll put that one there, this one here, this one here as well, and then maybe that one there, this one here, that one there. It feels like that's a good place, and then right there. Okay, wow, look at all these piles of 4 that we have. I'm not sure why I couldn't have done 5 columns of them, so I apologize for that. There we go. Okay, and everything's off center. Isn't that wonderful? Okay, well, let's go ahead and just take a look at what's in each of these, if we can kind of show you here. Okay, so there's one. Okay, I'm going to have to move some of these off so we can see what's going on. There's 2. There's 3. What's in here? Are you guys seeing anything interesting? I don't know if I am. Okay, and then we have, man, I am running out of room here. I need more camera real estate here. Sorry, move this up here. Golly, I don't see anything interesting about these cards. Do you? I really see. Are you seeing anything? Okay, maybe we'll do a little baby one here. Oh, you can't see it. You can now. Okay, very good. Then this one here. And then, of course, this one could go here. Wow, have you seen anything interesting here? I mean, these truly just seem to be random, right? I guess I was correct. We truly have just randomized these piles of 4 cards each. Oh, yeah, of course, sorry. Okay, now, before we started all of this, I actually wrote a prediction. I should have remembered this earlier. On the back of this piece of paper here, okay? So I don't know if I can slide these off without destroying everything. Okay, slide. Ooh, there we go, and slide. Okay, and that one's all messed up now. Sorry about that. Each pile, here's the prediction I wrote. There's just no way any prediction could be correct, right? Each pile of 5 cards have values whose names either have an even number of letters or an odd number of letters. Okay, well, I see a problem right off. Do you see a problem? Well, I can see that somebody doesn't know how to count. Well, I suppose we shouldn't say that this person doesn't know how to count. They don't know how to multiply, okay? Because 5 times 10 is 50, not 40, which is how many cards we have here. So let's go ahead and make a correction to some idiots right up here. Let's see, so there should be 4 cards, not 5. Okay, well, let's just see if the rest of it even makes sense. So each pile of 4 cards have values whose names have either an even number of letters or an odd number. What a strange prediction. Okay, well, I mean, think about how likely is it that this prediction could possibly be correct after all of the randomization of these cards into different piles, and then from there mix further and then reduce down to smaller piles and so forth. Okay, well, let's just check. Prediction says all of the piles will consist of cards that have either an even number of letters in their names or an odd number. Well, see, 4, F-O-U-R, with 4 letters in its name. Same thing for 5. Okay, so these all have an even number of letters. 3, T-H-R-E-E, was that 5? 5 is odd. Ace, A-C-E, 3 letters. Same thing for 10 and 6. What about those? Those all have 4 letters in their names. What about these? These all have 3 or 5 letters in their names, and those 2 numbers are odd. 3, 3, 3, 3. Yeah, these all have an odd number. Same thing here. What about over here? All have 4 numbers. Sorry, you can't see where I'm pointing here. 4 letters in their names. 4 letters in their names. Same thing here. Same thing here. And then this one I think we've already talked about maybe. So there's 3 or 5 letters in their names. Okay? As is the case here. Okay, so how in heaven's name could that prediction have come true after all of that mixing of these 40 cards? Okay? Now this is just kind of a simple example of preserving structure through tremendous, quote, randomization. Okay, so this is just an example of a 5-tuple Bessey sequence of order 8. Okay, well, let's go ahead and quickly step through what we've done and perhaps why things worked out the way that they did. Okay, so I started with a 5-tuple Bessey sequence of order 8. Well, specifically, what does that actually mean? Okay, so over here, as you can see, I have the structure that I actually used. Okay, and the way that we're condensing all of this information is we're using exponents to denote concatenation. This is not the ordinary use of exponents to represent repeat multiplication, but this is representing repeat concatenation. Okay, so it's a way of summarizing all of this into very few symbols. Okay, and then at the heart of it, you can see a Bessey sequence of order 8. 1, 0, 0, 1, 0, 1, 1, 0. So at the very heart of this, the Bessey sequence of order 8 is going to make all of this possible. Now, I'll tell you in a minute how I built the packet, but right now we're just kind of taking a bird's eye view of what it is we did. So imagine the packet of cards that I had set up and displayed for you to look at. And then we can perform quite a bit of mixing. I've just listed a few here that will not harm this 5-tuple Bessey sequence. Okay, so the one I used was a Klondike shuffle followed by an LR shuffle. Now this will either preserve this exact structure type or possibly invert it. Inverting it means zeros and ones switch places. That's all that means. So you can do a KLR. You can also do a Klondike followed by an up jog, even or odd up jog with random stacking. Okay, that would be fine. Of course, this first shall be last, last shall be first shuffle can be used because this sequence is invariant under packet reversals, because the invariance that we're looking for is we either want this exact structure type to be returned or its inversion. Its inversion is equally valuable, equally useful. And so if you remember this, dealing out into piles where the spectator says stop, stop, and then you stack from right to left, it just reverses the order of the cards. Okay. Now here's one that we did use as well, is I dealt down. And so can you see where I got confused on my write-up? Why I wrote 5 cards instead of 4. The 5 here is correct. It's correct here, but it was wrong in the prediction. Because 8 times 5 is 40, right? So I dealt down 5 cards into each of the 8 piles, even though the final 5 cards I just dropped on the table. Well, you can see why that would work, right? Because if this is the structure here, and I deal down the top 5, well, they're all of the same kind, okay? The next 5, they're all of the same kind. They're, quote, zeros. Next 5, and so forth. So it's like I'm kind of pulling apart the ones, the 2 sets of zeros, the ones, the zeros, the 2 sets of ones, and then the zeros. Well, because of the invariance of the Bessey structure relative to so many shuffles out there, once you've done that, you can actually stack those piles of 5 cards each from left to right, or right to left, or leapfrog stacking from left to right, or right to left. And all of those will either preserve this exact structure or invert it, okay? And that's what I have right here, okay? So now you can see where I got confused on the 5 cards there at the very end. It's supposed to be 4. Okay, and so here's the performance structure. So given a 5-tuple Bessey sequence of order 8, what I then did, in fact I could have done it better than I did it, actually. I could have given you more choices if I had just slowed down. But if you remember, I dealt out the cards into 5 piles of 8 cards each, okay? And how I could have done that is I could have done like 1, 2, 3, 4, 5, and then the next one could be 1, 2, 3, 4, 5. You can actually randomly create each level of that pile of 8 cards. Well, that's for the simple reason that the top 5 cards are all equivalent. They're all ones, so they can go anywhere. And then the next set of 5 are zeros, so they can go anywhere for the next level. And then same thing is true for the next set of 5. They're zeros as well. So I could have actually given you more choices. I guess I had kind of forgotten to do that. But boy, does that look like the spectator is very much deciding how these things are built. Let me just kind of show you what I'm talking about. So when I dealt those out into 5 piles like this, it actually doesn't matter how you build the next level, okay? So this one will go there, 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 there. Now you do need to complete a level, okay? That's important. Maybe this will start there and then there, and so forth. Okay, so I think you get the idea. So I should have given you the choice to tell me how to do that, right? I don't think I did that in the presentation, but you can and probably should, because it just gives the spectator even a greater sense that, boy, these cards cannot possibly be in any order that the performer could actually take advantage of, because of all of the random choices being made by the spectator. Okay, the spectator is very much in control of so much of this. Obviously not all of it, but so much of it. Okay. Okay. And then let's see. Oh, and then this is the name of the routine, I guess. Either even or odd value card names. Here's the prediction, which I can correct now. That's supposed to be 4. Okay, and so what you do is you create a 5-tuple Bessey sequence of order 8, where the ones will consist of cards whose names have an odd number of letters. All of these have either 3 letters to their names or 5. The zeros are going to be cards whose names have 4 letters in their names, right? Okay, so all of these, when you write them out, there's 4 letters in the names of those cards, okay? And so from there, what you do is you just build it up that way, okay? So let's, maybe just to pretend here, because I don't want to go through the whole setup. In fact, I'm going to show you kind of an example that simplifies all of this in just a second. So for those who hang around, you'll probably learn all of this a bit more deeply if you finish this video. So let's say these are the pile of ones. So these are aces, 3s, 6, 10s, and queens, hopefully kind of randomly mixed. This is the pile of 4, 5, 9, jack or kings, randomly mixed. Okay, so what I need to do then is I need to, in fact, maybe it might be helpful. Let's go back here for just a second. There we go. So we're building this. So if these are the ones, and you can deal down. We'll go ahead and get the inversion of this one. So I'm going to take top 5, quote, ones. Maybe I'll put those up there. And then I need 10 of these. 5, 6, 7, 8, 9, 10, like that. Okay, and then I need 5 of these. 1, 2, 3, 4, 5. And then I need 5 of these. Okay, and then I need 10 of these, which is actually all of the rest. And then the rest here will be 5 of these, right? And then you stack those. Technically, like I said, the zeros and ones have switched because I put the, quote, ones on the bottom or whatever. So anyway, this is the kind of structure I started with, okay? So it's not too hard to build, actually. It just takes a few minutes to separate the cards into these different card value name parity groups or sets, I guess. Okay. And then from there, what did we do? Oh, I mixed the overall structure. I did some mixing of the packet of 40, and then I created a, well, I'm not sure if I did this, actually. That would have been fun to do. Deal the cards out into 5 piles in a pentagon shape. I'm not sure why I didn't remember to do that, but that would be kind of cool to do. Now, as you build the layers or levels, the spectator can tell you where cards go. And then from there, we have 5 piles of 8 cards. Well, each of those piles of 8 cards is a Bessey sequence of order 8. Well, what that means then is you can draw on the many, many shuffles that preserve or invert Bessey sequences of order 8. And there's dozens of them that you can actually use. So you mix each of those independently, which is amazing that you can do that and not destroy any possible prediction being true. And then we decomposed each of them, because right now they're like each pile is like a 1, 0, 0, 1, 0, 1, 1, 0. Okay. Now we want to separate the ones from the zeros. Well, a great way to do it is using this triangle deal that I've shown elsewhere on the channel. This was discovered by Warner Miller, one of my subscribers. So it takes a Bessey sequence structure and converts it to this block of ones and block of zeros. Okay. Now, to give the illusion of kind of mixing the cards further, now, so technically, if you do this, the top 4 can be pushed off into one pile and the remaining 4 into another. Okay, so you could actually stop there. I mean, you would not have to go on and mix each of these 5 piles of 8 cards each. Okay, so you really wouldn't have to mix further. But to my mind, that just drives home that there's no way anyone could know anything, because the spectator's deciding on how to randomize each of these packets of 8 cards. So in one, I did a Klondike shuffle, I believe. I just can't remember all of the ones I actually did in the particular performance. And then, now think about it. When you perform the Klondike shuffle on something of this structure type here, it creates an alternating pattern of zeros and ones. Well, that's cyclic. So if you put out these little pairs, like you pull off the 1 and 0, it's like you have a 1 and a 0, 1 and a 0, 1 and a 0, 1 and a 0. Okay? Well, if you randomly stack these, you're going to have an alternating structure of zeros and ones. Okay? Well, once you have that, you can Charlier shuffle it or randomly cut the packet. It won't hurt it. Well, to separate an alternating packet of zeros and ones, you can just do an LR deal. That would draw off all of the ones and all of the zeros into separate piles of 4 cards each. Okay, so that's one I did on one of the packets. Triangle deal, and then I dealt out. See, if we have this, once again, you can go like 1, 1, 1, 1, and then the next layer can be put down however the spectator likes. So it's like you have these little pairs of 0, 1, let's say. And then if you randomly stack those, it's cyclic. Once it's cyclic, the Charlier shuffle can be used as many times as you like. And then I just dealt those out into 2 piles. Okay, that's going to separate the ones, the 4 ones from the 4 zeros. Here what I did was I kind of simplified it. If we have this structure now, just deal down the top 4 cards. That's a pile of ones. And the remaining cards are a pile of zeros. So you're set there. This one here, I just pushed off the top 4 cards and the remaining 4. Okay. And then the last one, I decided to do something different. I thought, okay, well, and you can do this same thing. You can say, well, using my intuition, I'll go ahead and just separate these cards into 2 piles, okay? And I don't even know why I'll put one card on the left and another one on the right. I'll just try to get little subtle impressions as to what I should do. Well, really all you're doing is, see right now, the packet structure, so we don't do the triangle deal for this one. Okay, so you're looking at a Bessey sequence of order 8. So if you remember, what I did was I did this like left, right. Probably should have put it above, sorry. So left, right, and then I did a right, left, and then I did a right, left, left, right. Okay, and so that will separate this Bessey sequence into 2 piles of 4 cards each, where one pile consists of the ones and the other one's the zeros. Okay, and then display the piles. Show a flash of recognition, like, oh wait, I forgot, I wrote a prediction for this, and then just bring out that your prediction and show that your prediction is correct. Okay, so I promised you that I would show you kind of a simplified version of a 5-tuple Bessey sequence of order 8. Okay, so what you can do is we'll go ahead and just have the ones, as depicted by the color, be red cards, and the zeros will be black cards. Okay, so this would be a way. So if we go ahead. Okay, so let's just go ahead. Maybe I'll speed up the camera here. Okay, so I've just separated the cards into a red pile and a black pile. That's all I've done. Okay, so what you can do here is, just follow it here. So we need 5 reds. 1, 2, 3, 4, 5. We need a black. 1, 2, 3, 4, 5. Another set of 5, of course. 1, 2, 3, 4, 5. Then we need a set of 5 red. 1, 2, 3, 4, 5. Okay. And then we need a 5 black. 1, 2, 3, 4, 5. And then we need a bunch of red. Well, that should be all of them. 2, 4, 6, 8, 10. Right? 2 sets of 5. And then a set of 5 black. Okay, so technically this is a 5-tuple Bessey sequence of order 8. Well, as you can see, I mean, it's pretty transparent that something is going on here. So we have 5 red, 10 black, 5 red, 5 black, 10 red, 5 black. Okay, so that's a little bit too transparent. Okay, so that's why I cast the routine in the way that I did in the original presentation. Okay, so I kind of essentially hid this structure by having the reds be even valued cards, or even valued name cards, and then the black being odd valued name cards, or vice versa. Okay, and then that way, really no one is going to be able to look at that and go, oh, I see what's going on. Whereas here, I mean, it looks highly suspicious, right? But this does help bring out the structure. Okay, that's the key. Okay, and so if a person, in fact, this might be something helpful for you to do if you're interested, is go ahead, create this packet here. So that's not too hard to create. It won't take too long. And then step through the very routine that I showed you at the beginning. You know, after the performance, I showed you a write-up of the steps. So go ahead and step through all of those. And what you'll see is you will separate all of these cards into 10 piles of 4 cards each, and each pile of 4 will consist of cards of the same color. So you have a pile of 4 cards, they're all black, you have another pile of 4 cards, they're all red, and so forth. Okay? So really amazing that can be done with so much spectator input as to how things are done. Okay, and it really is the invariance up to inversion of the Bessey sequence of order 8 that is the true engine driving all of this. Okay, so if we didn't have those amazing properties of invariance for the Bessey sequence of order 8, this wouldn't have worked. Okay, or if it worked, it would be a 1 in who knows what large number, 10 to the 57th or something. Okay, so anyway, this completes this 4 video series devoted to n-Tuple Bessey sequences of order 8. Now, I don't think I'll do n-Tuple Bessey sequences of order 32, okay? Or even a quasi n-Tuple Bessey sequence of order 16. For the simple reason, I guess I could almost do 16, but for the simple reason that it quickly exceeds the number of cards in a standard deck of cards. So I guess if I did a 2-tuple quasi-Bessey sequence of order 16, I would only need 32 cards. And if I did a 3-tuple, I would need 48, which is still within the deck size, I suppose. But I'm hoping that doing what I've done in this series, you'll be able to see what it is that's driving the whole effect and how you can take advantage of a smaller invariant structure like a Bessey sequence of order 8 or a quasi-Bessey sequence of order 16, and then build larger packet performances that nonetheless rely on the remarkable properties of Bessey sequences and or quasi-Bessey sequences. And maybe as a quick reminder, a quasi-Bessey sequence of order 16, let's say, the reason it's called quasi is because it enjoys some of the invariance of Bessey sequences of order 8, but not all the invariance. So there's some shuffles that will preserve or invert Bessey sequences of order 8, but they'll destroy quasi-Bessey sequences of order 16. But many of the shuffles that work for a packet of order 8 also will preserve or invert a Bessey sequence of order 16. So anyway, that's why they're called quasi. They're not quite, they don't have this quite the same degree of invariance relative to the common shuffling procedures that people use today, systematic shuffling procedures. Okay, well, thank you for watching, and look for other new videos on this channel. There's many, many more to come. And I've reorganized the playlist. I've tried to do it in such a way that maybe it's easier to navigate. And I've created many more thumbnails for them to make them a little bit more interesting than just looking at a write-up or piles of cards on the table. So anyway, well, thank you for watching, and I appreciate your support. And if you're interested, go ahead and subscribe and like this video. And I hope that you'll join me in other videos on the Hidden Structures channel.